So we're about to cut open this converter. We've got our points marked for realignment. We do all of our converters in-house. And as you can see, with each stopping point, 3 different arms came in here. This is a factory OE converter, never been cut open. 3 different arms came in and welded this sucker shut at the factory. We're about to see what's inside. How much metal's caked in from the failure. We're gonna update this guy and manipulate stall. We're cutting open the torque converter now. In minutes this thing will be apart. What we're doing is just cutting the weld so we're able to separate the 2 halves. Bada bing. There you go. Low stall 4L60E OE converter just cut. Bone stock. And the 4L60Es have dual bearings. The TMBX converters have dual bearings from the factory on both sides. But we're going to be doing an updated Sonex aluminum stator cap, which has better oil flow. And we're going to be doing the updated Torrington bearings, which are thicker and have larger rollers for the side facing the turbine and the side facing the impeller. And this is a woven clutch for the PWM, which is pulse width modulated, and they call the EC3 strategy. That is this correct lining for the truck application. We're going to be doing some change ups. We're still going to leave the PWM function, but we're going to be deleting the EC3. So I'll be doing some mods in the valve body and the pump, and still utilizing the same lining, but the converter clutch is going to have more of an on-off function instead of a ramp on, ramp off, and PWM function. We will continue with more videos as this converter progresses. So here we have the stator, and we're just doing a little pre-clean right now. We're going to be machining this down for stall. The ultimate goal for the truck is right around 2400 stall. I'll be chucking this up in the lathe and machining the fins down a certain amount that I like to do for stall, and I'll be also manipulating the exit fins for the impeller and trying to achieve that 2400, maybe 2500 stall range. Some of the updates we're going to be doing to the stator, we're going to be updating this aluminum stator cap with a Sonex stator cap, which has improved oil flow slots. This is actually more of a harder, almost like an anodized aluminum. They're really, really excellent as far as wear characteristics, and they have the oil slots to squeeze the oil in underneath the bearing, between the bearing and the turbine hub. The bearings themselves are also going to be updated. This is the factory bearings that came out of it. These mic out at right at about 170. I'm sorry, 158 to 160, kind of in that range. There's about 158 right there. So the bearings that are going in it are Sonic's Ingersoll Rand coil bearings, which are thicker, and they have larger rollers. And so I'll be using these not only for wear and thrust capabilities of the thicker bearing, but I can also increase my overall stack height of the converter before I weld it together, so I can actually build more installed height into the finished converter. So it will hopefully eliminate needing to shim between the front lid and the flex plate. Lastly, for the spring and rollers for the Stator, it'll be getting all new spring and rollers, and the roller assemblies once again be Sonic's, and the accordion Stator springs, these are the old ones obviously, those will be updated from Sonic's to this style, which is a slightly stiffer accordion spring than what GM originally had put in them. And they actually have a little receiver notch for where the roller sits, and a little flat pad where it sits in the Stator ramp. So if you compare it to the old one, this is the new Sonic's, and this is the old. It actually has the, like I say, the little receiver pad, whereas that's flat, and this kind of has somewhat of a receiver pad, but it's not as aggressive. And so these factory GM springs want to kind of roll it and then push the whole spring towards the inner race, whereas this keeps the spring straight up and down in the Stator. And then plus it's just a little bit taller and a little bit stiffer than the factory GM one. So I use these for all of the 4L60E, 4L65E torque converters. So we're going to go ahead and get the converter going in the jet washer. I'm going to fire it up here pretty soon and run this thing through about 3 times to get all the clutch material and oil and grit and grime off this, and then get it ready for some of the machining steps. So we're going to be machining the Stator, and we're going to be machining the entrance side of the Stator fins, manipulating stall. I've already done my calculations with the axle gears that are going in this truck and the engine, and what the end result's going to be down the road with gear changes and other cam changes. So I have a really, really good idea of where I'm going to machine the Stator at, and I'm only machining one side of the Stator. So the stall, projected stall, should come in at right around 24 to 2500. If this 4.8 liter engine ends up generating more low RPM torque, the stall could possibly be 2800. If it generates less low RPM torque, the stall could be closer to 2300. But either way, it will be a really, really good little street rod torque converter when it's finished. So we will update it here in a little bit when we get some machining done.
the stator's all done. Done machining to get the stall we want to achieve when the motor and the rear end's in it. We were deciding on either we wanted to keep the fins flush or give it a window to increase stall. We decided to give it the window for the 410s and the turbo and the cam I'm going to be putting in the truck down the road. So I think with the way we went with it, it should give me the stall that I want when the build is complete. But this was our trial, so we'll see how it goes.
So the stator's all been machined up like we did at the lathe. It's been thoroughly cleaned 3 times, getting all the aluminum shavings and filings. Compressed air was used, blowing out all of the little chambers, and so it's totally clean. I've cleaned up the inner race, the snap ring, brand new Sonics stator cap with the oil slots, and the rollers are all ready to go. So it is all ready to be assembled. Basically putting the stator race in, loading the rollers, and putting the springs in, and once that's all done, then put the cap on and the snap ring, and then check the one-way function of the stator, and this is ready to be set aside until the torque converter is all machined up and cleaned up and ready to be jigged and then welded and put back together. So the stator one-way roller clutch is all built. The new rollers and springs are all installed. The function of it's been checked. So it releases counterclockwise and it locks clockwise. So the stator one-way clutch is locked when the vehicle's in a dead stop, and then the torque converter is under torque multiplication because the fluid then is redirected because there's resistance pushing against the stator and the one-way clutch is locked. Once you get to about 30 to 35 miles an hour, then the stator itself then starts to freewheel because the roller clutch releases because the fluid changes direction, and so no longer is the fluid pushing against the stator, which is locking the clutch. It's pushing the opposite direction, which then is unlocking the clutch. And once again, that's at about 30 to 35 miles an hour. So this is all ready to go, ready to put the cap on, the snap ring, and set it aside until we put the converter together. So just prepping the outside of the converter impeller, and then I'm going to dress and prep the top lip where it welds, and then the inside, and then take off the old balance weights. And I've already prepped and dressed the lid over here. So this is all prepped and then glass beaded to get off any old weld slag from the previous GM weld operation. So that's all ready to go. Once I'm done with this, these 2 parts will go in the jet washer, get all cleaned and final rinsed, and then ready for the jig up and then weld together. Going to cut out the spot welds for the weight. Sometimes it goes easy and sometimes it fights. Okay, that one's just about done. Okay, that one's done. Move on to the next one. just taking off the remainder of the weld lip from when the converter was originally welded together, and I'm just sanding it down so that it's completely flat, and this little raised lip is gone, and then the front lid can easily fit right in and be ready for welding. So it should be coming off. If I drilled through the weights far enough, she should just come right off here. I'll grab my little big one. And you got to do a lot more on this side, and then hopefully she just comes right off. So got the weight off the bowl, and now I'm going to sand down, grind down these two spot welds, get it nice and smooth and flat, and then just do a quick little touch up all the way around on the outside edge, and then she's ready for a final wash. So sometimes it can be quite the project getting these little weights off without damaging the bowl. So there you go. Got a little more to go, and you can see how that one's already gone and nice and smooth, so we'll finish this up in a little bit. Okay, the parts are going in the jet washer for the final time to get all the metal filings and shavings and everything else off of them, and then we're going to jig it up and weld it. Okay, so I got all the parts all cleaned up. Just going to do a quick little jig and verify the overall height of the converter really quickly here. We have the Stator, brand new Torrington GM20 bearings. Stator's all machined down. New stator cap and spring and roller kit like we had in the previous video. New bearing for that. And then here is the turbine. There's a new O-ring that goes on the back of the turbine hub, which then when you put the clutch dampener in, this O-ring seals the inside portion of the clutch dampener, so when the torque converter is called to lock up from the computer and it sends a hydraulic signal through the input shaft, which also has an O-ring on it, it then pushes against the O-ring here, and it pushes against the front lid, or excuse me, the dampener, and then that engages the front lid. So that's how the lockup works. So anyways, we're gonna get back to it and get her jigged up. So we got the clutch dampener on the back of the turbine, and I just laid both in together inside the front lid. Forgot to take a little videotape of that, but it's already installed with the new O-ring on the back of the turbine hub. And now we're going to put the bearings and the stator in, and these bearings are directional, so they go one way. You don't want to have them flip the other way. So bearing on top, it hangs up, and then the stator right there, and then this bearing Tang's facing the stator. Here we go, and now the lid. Look for my alignment dot. Now she's ready to be jigged and spot tacked and go in the weld machine. So we'll verify the height, and then we're going to verify the bowl run out and get those set, and then spot tack it. Now. Come on.
Converter's all welded up, pressure checked for clearance. We're going to do the final clearance check here in just a few. Nice consistent weld. No bubbles when it was dunked. No leaks anywhere. So we'll keep at it.
So this little fixture here checks the internal thrust inside the converter, and attached to the other side of this arm is a rod that pushes on the turbine inside the converter, and that's what that little tap noise is the rod pushing against the turbine, which that's how I verify the thrust. So converter's flipped upside down, got her set to 0, and then we'll check the thrust. And the internal thrust is right at 18 thousandths, and that is perfect for this type of converter, which is a woven lining TMBX. So the sweet spot on the internal thrust of a converter is between 10 and 30 thousandths on a woven setup, and this one comes in right at 18, so she's perfect.
Well, the converter is finished. We have all of our modifications written on the top there, on the bowl. Have our stamping down, 2024 2400 stall, extreme, heavy duty. It is done. We hooked it back up to our measurement machine, and we're sitting right about 9 thousandths there, approximately, which isn't perfect. We'd really want to hit around 4 thousandths. In a perfect world, 2 thousandths, but comparatively to some of the reman shops that do it at a fast pace, they usually sit around 20 thousandths or more. So we're pretty happy with that measurement there. That's the pilot to hub run out. So yeah, we're complete. We are ready for installation. We have our weld sandblasted, looks really good all around. And yeah, we're gonna put about a half a quart of ATF in here just to lubricate the internals for the first fire over. And we're done here. So thanks for watching the video. Stay tuned for more to come on the channel.